Hey, welcome. Ever stop to think about what your brain is really doing all night while you're asleep? We think of it as our body's downtime, but it turns out our brains are working overtime. They're not just offline, they're actually tidying up, reorganizing everything, and basically making us smarter. So today we're going to dive into some amazing research that shows how sleep is like our brain's very own master editor.
Really think about that for a second. Every single day, you're just bombarded with stuff. Conversations, things you read, new faces, random facts. If your brain just kept piling all that information on top of itself without ever cleaning house, it would be a total mess, right? It would just get overwhelmed. So what's stopping our brains from basically running out of storage space? That's the big question we're digging into today.
Well, the answer might be hiding in a pretty shocking number. We forget about 50% of new information within just 1 hour. Yeah. For a long time, scientists saw this as a weakness, a bug in our memory system. But what if it's not a bug at all? What if forgetting is actually a critical feature that keeps our brains running smoothly?
Okay, so to get to the bottom of all this, here's our game plan. First, we'll look at the brain's storage problem. Then, we'll check out the stories so far in sleep research. After that, we hit the really exciting part, the breakthrough. And finally, we'll unpack what it all means for you and me.
All right, first up, let's really break down this core challenge. So our brains learn by making connections between brain cells, between neurons. These are called synapses. And the more we learn, the more connections we make. But here's the thing, that process can't just go on forever and ever. There has to be some kind of balance.
And that balancing act has a name, synaptic homeostasis. The easiest way to think about it is like a librarian for your brain. You can't just keep cramming new books onto the shelves, right? Sooner or later, you've got to clear out the old, less-read books to make space for the important new ones. And that's pretty much what synaptic homeostasis does for our brain's connections.
And why is this so critical? Well, without that balance, our brain circuits get totally overloaded with what scientists call noise. It's just too much information. And that static makes it way harder to form sharp new memories. Plus, it burns a huge amount of energy. The part of the brain that gets hit the hardest by this is the hippocampus, which is basically our memory headquarters. It's a system that needs precision, not just a mountain of data.
So scientists knew this balance was a big deal, but for decades, they had no idea how the brain was actually pulling it off. To really get the new discovery, we first have to look back at the story so far and how our whole view of sleep has changed over time.
As recently as the 1920s, the common wisdom was that sleep was just downtime. The brain switched off. But then, in the 50s, the discovery of REM sleep showed, whoa, the brain is actually buzzing with activity at night. By the 90s, we figured out that sleep helps lock in our memories, making those connections stronger. But that only explained one side of the coin. It showed how we remember, but it didn't explain how we forget.
This quote from one of the researchers really just hits the nail on the head. Science knew the brain was adding clay, building up the sculpture of our memories. But any great artist knows that carving away the extra bits is just as important as adding new material. The hunt was on, to find the brain's chisel.
And that leads us right to the most exciting part of this whole thing, the breakthrough. This is that aha moment, where scientists finally figured out how the brain actually takes out the trash. And here it is. The big breakthrough was realizing that sleep isn't just about strengthening memories, it's also about weakening and removing them. During that deep REM sleep, the brain is actively trimming away the weaker, less important connections. By clearing out all that clutter, it frees up energy and space to make the important stuff even stronger. It's incredible. Forgetting is actually the secret to remembering.
So how in the world did they figure this out? Well, they had a hunch that some kind of biological marker had to be responsible. So, using these incredibly powerful microscopes, they tagged individual synapses in the brains of mice and literally watched them as the mice slept. And what they found was this one specific protein called synapsin 3A. It would flood the brain during REM sleep and attach itself to the weaker connections, basically marking them for demolition.
And the results were just wow. Take a look at this. The normal mice, they had great recall of tasks they'd learned. But the mice where they blocked that synapsin-3A protein, their memory was terrible. Their brains were just full of that noise we talked about, because they couldn't prune away the trivial stuff. They literally couldn't tell the important memories from all the junk.
Now, this isn't just some cool fact about mice. It has some seriously profound implications for every single one of us. So let's zoom out and look at the bigger picture. What this new understanding of memory really means for us.
This discovery really changed everything.
I mean, the old view was that forgetting is a failure, a passive mistake. The new view is that forgetting is an active, deliberate, and essential process. Sleep doesn't just reinforce memories, it strategically deletes unimportant ones to make you smarter. It just completely reframes how we think about learning itself.
So as we wrap up, what are the big takeaways here? First, and this is huge, forgetting is not your enemy. It's your brain's secret weapon for efficient learning. Second, getting good quality sleep, especially that deep REM sleep, is absolutely non-negotiable for this editing process to happen. And finally, this opens up some incredible new possibilities for treating things like PTSD, where you might want to weaken traumatic memories or maybe even age-related memory loss.
And that leaves us with one last, kind of mind-bending question for the future. This research is really just the beginning. As we learn more about how to influence our brain's nightly edit, we have to start asking ourselves, if we get the power to choose which memories to keep and which ones to throw away, should we? What would that even mean for who we are? Definitely something to think about. Thanks for joining me.